Okay, so this is day 68, finding values of trig ratios. Okay, so we did a little bit of this yesterday's work. If you have, if you know the cosine of theta is less than 0 and the tangent of theta is less than 0. Okay, so if cosine is, and you have to justify, you have to say, okay, where does this happen? Where does this terminate? Or if it doesn't exist, then why does it not exist? Okay, so if the cosine of theta is equal to x over r, which is less than 0, then that means x is less than 0. Because r is a distance, so that's always going to be positive. So if x is less than 0, then theta must terminate left of the y-axis. Okay. And if the tangent is also less than 0, then y has to be greater than 0 because x is already less than 0. Like, we know that, okay? Therefore, theta terminates in quadrant 2 because quadrant 2 is where x is negative and y is positive, okay? We could say, all right, what if, I may not write this one out completely, I may just talk because you can pause and write as I talk. So what if the cotangent of theta is undefined and cosine of theta is less than 0? Okay, well, if the cotangent of theta is undefined and cotangent of theta is x over y, but it's undefined, then that means that y has to be equal to 0, because that would mean that you're trying to divide by 0, and division by 0 is undefined. So if y is equal to 0, then it has to terminate on the x-axis. And then the next hint is that the cosine of theta is less than 0. And remember, cosine is x over r. And it's less than 0. So x has to be negative. Y has to be 0. So theta would terminate on the negative x-axis. The negative x-axis. All right, let's do some of those that we were talking about with the passes through this, passes through that. Okay, so we have this angle alpha. So alpha is this little fish looking thing. Okay, that's alpha. And alpha passes through 5, negative 3. That's what alpha does, okay? My suggestion to you is to, first of all, draw a picture. Illustrate that. So 5, negative 3 would be down here. And the reference always goes back to the x-axis. That's 5, negative 3. Here's my right angle. And I know that x is 5. I know that y is negative 3. And if I use Pythagorean theorem, I can find r. Because r squared equals x squared plus y squared. So r squared would equal 5 squared plus negative 3 squared. So that's going to be 25 plus 9. So r squared is 34. So r is the square root of 34. And we're just going to leave it as the square root of 34 for now. Okay? And I know it's plus or minus, but that is a distance from here to here. So it is just the square root of 34. All right, and then find the exact value of the 6 trig functions. Okay, well, the sine of alpha, if you'll remember, just write my alpha upside down there. The sine of alpha would be y over r. So that's going to be a negative 3 over the square root of 34. Cosine of alpha would be x over r. So that's going to be 5 over the square root of 34. Tangent of alpha would be y over x. So it's a negative 3/5. And by the way, we're just going to leave that. We're not going to rationalize that denominator right now. I don't really care. All right, so cosecant is the reciprocal of sine. So the cosecant of alpha would be a negative square root of 34 over 3. Secant is the reciprocal of cosine, so that's going to be square root of 34 over 5. And cotangent is the reciprocal of tangent, so that's going to be a negative 5 over 3. And that's it. Okay? And then, like, you can also do like a mystery with this. It could tell us, it could say, suppose that the sine of alpha is a negative 3/5 and that tangent of alpha is less than, how about less than 0? Okay, where does it terminate? Well, if sine of alpha is y over r, which is a negative 3 over 5, then y equals 3. Sorry, y equals negative 3. So it has to be below the x-axis. And tangent is also negative. So if tangent is negative, that means x is positive. So it has to be in quadrant 4. It has to be in quadrant 4. All right. You could figure out what it is from that. You could draw it. You know it's in quadrant 4. You know that y is negative 3. You know that that's 5. You can use some Pythagorean theorem to figure out what x is. You got 25 minus 9. So x squared is 16, so x would be 4. And then you can find all your other trig functions from there. You can do the same thing with an actual linear function. Let's say you've got an angle beta. That's beta. And the terminal side lies in quadrant 2 along the line 2x plus 5y equals 0. So we want to order sine, tangent, and cosecant from least to greatest. Well, in order to do that, we have to actually find them, right? So let's draw this out a little bit. We know that it is in quadrant 3. So it's here somewhere. And we also know that it lies along this line. Well, if this is the line, that means 5y equals a negative 2x. So y equals a negative 2/5 x, right? So 0. I'm going to take that backwards. I'm going to go up 2 and over negative 5. So that's the line that it passes through right there. There's my reference triangle. That's 2. That's negative 5. So 2 squared is 4. Negative 5 squared is 25. So this is the square root of 29. So you can find your sine, your cosine, and your tangent. The sine of beta would be y over r. So that's going to be 2 over the square root of 29. What else did I say? Tangent. Tangent of beta would be, let's see, negative 2/5. And cosecant of beta would be square root of 29 over 2. So then order from least to greatest. Is that what I said? Yeah, least to greatest. So least would be the tangent. And then the sine. And then the cosecant. Alright, so you saw like a little mystery with these. My biggest help and hint to you draw a picture so you can see in front of you what you're dealing with, and then go from there. All right? Okay, I'll see you next time.